Hello, ladies and gentlemen. Welcome back to my channel. My name is Mr. Arias, and this is Math to the Point. In today's class, we're going to talk about the effect of the value of h in a quadratic function in vertex form. Just to recap, a quadratic function in vertex form is basically a quadratic function that has the following structure. F of x is equal to a times x minus h to the power of 2 plus k, where the values of a, h, and k can basically be integers, decimals, or fractions. And technically speaking, when you're looking at these effects of h that happen on these quadratic functions, what's going to happen is two things. Number one, if the value of h is bigger than 0, which means it's positive, the parent function will move or shift or translate to the right h units. I'm going to talk in a second about what the parent function is that I'm talking about in this case. For the second case, if on the other hand the value of h is less than 0, which means it's negative, then the parent function will move or shift or translate to the left h units on the coordinate plane. Now, why am I saying the parent function? So just so you know, when we talk about quadratic functions, whether we're talking about vertex form, standard form, or intercept form, we're basically having the same starting point, which is this parent function that I'm going to define as f of x is equal to x to the power of 2, which is the graph that I have on Desmos right here on the screen. So if you notice, this is a quadratic function that is opening up and whose vertex is located at the origin, which is the point 0, 0. This is the most basic and the simplest quadratic function that we can ever have when we're talking about these kind of functions. And in fact, any other quadratic function in existence comes from this function. So technically speaking, all the other quadratic functions that we have and we're going to be studying in this class are going to be variations of the mother function or the parent function or the father function, which is f of x is equal to x to the power of 2. So from now on, if I'm talking about the parent function, please keep in mind that this function is f of x is equal to x to the power of 2. Now, let's investigate these changes that we're talking about in case 1 and 2. So how is this value of h that we have in this equation of a quadratic function in vertex form going to change the behavior of this parent function f of x is equal to x to the power of 2. So I'm going to basically begin by choosing this second function, which I'm going to call g of x. And I'm going to choose a simple value of a, which is 1, because that doesn't change the opening or the shape of my function, of my mother function here. And then here, I'm going to be opening these parentheses in which we're going to have the quadratic expression. And then the value of k will basically be 0, because we're not going to investigate that in today's video. That's going to happen in a different video eventually this week. So I'll be placing a value here. I'm going to just choose any random value so that you can see what happens if, let's say, I put a 4 in here. So if you notice, we generated a new function, which has now the vertex located at this point here, which is the point 4, 0. So technically speaking, what happened is that this function, the mother function, shifted or moved 4 units to the right-hand side along the x-axis. Okay, so in this case, I have this 4, which happens to be negative. So what happened is, visually speaking, my blue function is translated. It's basically as if my original function, f of x is equal to x to the power of 2, had been moved to the right-hand side. And here is where I have a lot of questions and where my students get a little confused. Because they say, hey, Mr. Arias, this is kind of the opposite of what you're saying. So we said that if the value of h is positive on this structure of the quadratic function in vertex form, then the parent function would be moving to the right-hand side. But in this case, the value of h that you chose is negative. So how is this even happening? It's the opposite. And this is the question that I would like to address in this video. So you have to remember, ladies and gentlemen, the following. So the equation of a quadratic function in vertex form is the following. F of x is equal to a times x minus h to the power of 2 plus k. Pay attention to this negative value that's located between x and h. That is a symbol that I'm going to call a mandatory negative. So this comes with the equation, with this formula. We can't possibly change it. We can't possibly modify it as it is right now. So check it out. If I'm choosing this equation, and let's say that I want to choose a value of h that is positive, what would happen is the following. So if I choose, for example, a value that is positive 4, let's say my h is positive 4, if I replace it into this equation, what would happen is the following. I take this h off, and then I'm going to replace it with the positive 4, right? So we end up with the following expression. We have a times x minus positive 4 to the power of 2 plus k. Because again, this negative, we can't possibly change it as of right now. And then my observation is what happens anytime that we have a minus symbol next to a plus. It simplifies to a minus, doesn't it? So that's exactly why we end up getting just x minus 4 as opposed to x plus, minus plus 4. It's exactly the same thing. So technically speaking, what I'm saying is that even though in my equation up here, we have an h that seems to be negative, in reality, it's originally positive. But it appears to be negative because of this mandatory extra negative sign that appears in the equation of this quadratic function in vertex form. Okay, so that's why my bullet point number 1 is still being respected because the value of h is positive. Hence, we experience this transition or this movement of 4 units to the right-hand side on the coordinate plane. Now, let's see what happens if we do the opposite. Let's say that instead, I change this to a plus 4, okay? So now we have the opposite effect. Now the vertex of this function is on the other side of the x-intercept. Now this is located at the point -4, 0. Okay, so it's basically as if we moved the mother function or the parent function to the left-hand side, h units there. Now, again, you might be confused and say, hey, that's kind of the opposite. If h is negative, the function should be moving to the left, right? But in this case, it seems to be positive. It's counterintuitive. So what's happening? Same explanation, ladies and gentlemen. Again, please go by the equation of your quadratic function in vertex form, which is the following. So we have a times x minus h to the power of 2 plus k. So let's see what happens if I choose a value of h that is originally negative and I replace it inside this equation. So if I choose, for example, a value of h that is, let's say, -4, what would happen is this. I would have to replace the value of h from the equation with the -4. And again, I can't possibly do anything about the other negative that is located between the x and the value of h. And guess what? We end up getting this situation in which we have a double negative. What does that simplify to? To a positive, right? This becomes a positive. So basically, this eventually becomes this expression. And again, keep in mind that the value of k in this example is 0, just for simplicity, but eventually it can have any other values. But for now, my point is that even though in this parentheses, there seems to be a value of h that's positive, in reality, that value of h was originally negative. Hence, the change to the left-hand side on the coordinate plane. So that's basically this topic. This is what happens to the parent function, f of x is equal to x to the power of 2, when we change the value of h. And don't forget that mandatory negative symbol between the value of x and h. And technically speaking, for the rule of thumb that I want to give you right now is if in your equation the value of h seems to be positive, in reality, that value of h is originally negative. And if it seems to be negative in the equation, in reality, that value of h is originally positive. Okay? I hope this video helps. Ladies and gentlemen, have a wonderful day, and I'll talk to you next time. Bye-bye.